Here's your Integrated 3 lecture for 12.1.3. You're going to learn about the inverse functions of inverse sine, inverse cosine, and inverse tangent. And instead of you, if we were in class, we would have you drawing them and figuring out what the inverse is by reflecting over the line y equals x. But instead of assigning you that, I want you to watch the video that I put up on the Google Classroom from the organic chemistry tutor, because he's going to explain all this. And then I'm going to just do 12-33. It says consider the equation sine x equals negative root 3 over 2. How many solutions does the equation have? So I know that I can plug in infinite solutions, because if I look at the unit circle where sine of x is negative root 3 over 2, well, I see at least, so sine is the y values, so these are positive up here, but y can be negative down here, and so there's a negative root 3 over 2 at 4 pi over 3, and sine's negative root 3 over 2 at 5 pi over 3, and if I go around the unit circle again, I can add 2 pi to 4 pi over 3 and get another angle measure, like a bigger angle measure. I can keep adding 2 pi and going around and around the circle, same thing with this location. So there's infinite solutions, and even if I looked at the graph, negative root 3 over 2 is approximately negative 0.86, and so on a graph, I could find so many different places, all these different places, depending on how far I'm willing to go. I can find angle measures that give me negative root 3 over 2 as the sine ratio. So on A, we're going to say infinite. And then on B, without using a calculator, list the solutions and show them on the unit circle. Well, I just had my unit circle out a second ago. It's right here. And I remember that it was 4 pi over 3 and 5 pi over 3, where I can get a sine value of negative root 3 over 2. So I'll just kind of draw a picture of that. Okay, and then, so there's my drawing, and then I can write this as 4 pi over 3 plus 2 pi n, which means I can keep, if I go around 4 pi over 3 radians, I can find that spot where sine is negative root 3 over 2. But then if I want to find it again, I can add 2 pi, because that's how much it takes to go around the circle each time. 2 pi, and I can just go around, as the n is, I can go around as many times as I want. I can even put negative values in for n if I want to. This one, I'm going to get another solution of 5 pi over 3 plus 2 pi n. So that's the answer for letter B, that and my picture. And then for letter C, it says, which solution do you predict your calculator will give? How do you know? Once you've made your prediction, use your calculator to solve it, and were you correct? So in the video that I hope that you already watched before you watched this one, the tutor on there starts showing you how we are going to restrict the domains of our trig functions when we get the inverse trig functions. And so the domain of sine is going to be in, here, let's just go like this, in this quadrant and quadrant 1, and in quadrant 4. Okay, that's our restriction of, that's how we restrict the domain. And so, but we know that sine is positive in quadrant 1 because everything's positive in quadrant 1. Sine is a y value. But we're talking about negative root 3 over 2. So we know it has to be in this answer that we get when we ask our calculator what is the sine of negative root 3 over 2. It has to be in quadrant 4. I mean, we know it can also be over here, but we have a domain restriction that puts it in quadrant 4. So it says, which solution do you predict your calculator will give? I think it's going to give me 5 pi over 3. So I don't know. Let's get into radian mode and check it out. Am I in radian mode? I can't even tell. Well, it's a little tiny and I can't read it. I think it's a little r. So I want to take the inverse sine of negative, where's my root 3 over, oh, I know what to do. Okay, so there's negative root 3 over 2, and I want the inverse sine of it, so I'm going to shift sine and then push my answer key to avoid the problems I was having earlier. And I got negative, okay, so negative, this is equivalent to negative pi over 3, and I can see that that is true because if I open up my angle this way, that is negative pi over 3. That's negative pi over 6, negative pi over 4, and negative pi over 3. So that is the quadrant 4 solution. That's just another 5 pi over 3 and negative pi over 3. 5 pi over 3 is how you would say it if you start here and you go all the way around to there like that. That's 5 pi over 3. That's the distance 5 pi over 3. But if you open up your angle going the wrong way, we say it's negative pi over 3. So that's how my calculator gives it. Okay, and then was I correct? Yes, sort of, except for I didn't know my calculator was going to give me a negative angle measure. Okay, so the rest of it, this is all covered in your other little YouTube video that I assigned from the organic chemistry tutor.